dataset model, and I'll make that, depending on your interest, maybe look at oriented imagery again. I forgot to say one very important thing up front. I have tons of slides on this. Lots of things that I say I have in slides, but I don't show the slides. I show live things in between. You will get all that information, right? I will share that with you. I'll give it to Christine or Trin, and they will prepare a downloadable set of these presentation slides for you, so you have it. It's always good to take notes. I do the same thing, but just be aware that all the stuff that I use, you will actually get. To start with this section, I want to show you a sample data set. The good thing today is that there is so much free and open governmental data that you can do nice things, and you don't have to ask for data permissions. This is one of them. The Swiss Topographic Institute has made all its data all of a sudden open, so we can use it and look into it. If you look at this, if you know Mosaic datasets, you see my dataset condenses on a very, very small spot. And all I'm going to do now is I'm zooming in slowly into the area of Zurich. Now my disk needs to wake up before we can really get started. And now it should be a lot better. If I do that, you see standard topographic maps of Switzerland, but you also see this changes. So if I zoom in, different topographic maps show up. Give it a chance to catch up, and more and more. That wasn't enough. Okay, here we go, and then here, and at some point we reach the highest resolution level of their topographic maps, 1 to 10,000 or something. So this is a single Mosaic dataset, but apparently it shows different levels of data. Now, not enough with that. If I am at this highest level of resolution, I can also decide that I want a different data compilation for it. So I have these processing templates in here, and I can actually say, hey, whenever I get to a very high resolution, I actually want to see the aerial image. Outside, I want to see the topographic maps. Switzerland, as you know, is a tourist country, and it has a lot of winter. Maybe not as much winter as you have, but a different kind of winter, more the skiing kind of winter. For some reason, they have decided they also have winter topographic maps. Well, why not look at the Swiss winter topographic map? Okay, now everything gets cold and blue and you name it. It is still the same Mosaic dataset. So if I now move in and out, I get the winter topographic maps in the different scales. They've also released high resolution elevation data. So I changed that thing again, going back to summer elevation map. But now if I zoom in, I don't want to see the aerial image. Now if I zoom in, I want to see a very nice shaded digital surface model with actually a very customized function to shade it. The one single message that this should show you is that I'm having collections of data, and it's my decision which of this becomes relevant in terms of scale, in terms of content, and presenting it. And all this is in one single Mosaic dataset. Now, who of you has been creating and working with and using Mosaic datasets? Can you raise your hands? About half of you. If you sort of follow the standard procedures, very likely you sort of learned create Mosaic dataset, add rasters, build overviews. Which basically means what you would have is something like pyramids on top of a single raster. You would have always the same content, but at different resolution levels accumulated to less pixels, basically. You don't have to do that. The Mosaic dataset can do anything for you. Any data compilation, any kind of bits and bands and orientations and resolutions, and it can combine all of that.
But what about performance?
The performance is highly depending on /C presentation number 2 this morning. It's only depending on how much effort do I have to access the data and the data pieces, and the only second part that becomes relevant is how much processing do I add on every single data set before I can use or display it. We'll talk about that. Why is that? Why is this important? Well, first, before I go back to PowerPoints, I will just open the attribute table of this data set, and that already is one of the key messages. What is a Mosaic data set before everything else? It's a system of tables. It is a database structure. It lives on selections, queries, and things like that, like any other table or database. So it can do tons of things for you just because of that logic. I like to teach you one function that is helpful if you're sitting in front of that screen. You know what happens if I press the Shift key and roll the mouse wheel forward when I'm on top of a table? Something nice if the table is active. Not the Shift key. It makes it nicer to read. Right? Okay, so what you should see here is that in the name column you see that I have these different data sets integrated here. Swiss surface, that's elevation data. Swiss map, that's the topographic map. Swiss image, that's the high resolution aerial images. So they're all just listed as part of this data set, right? Everything that I'm using here to be able to switch and do these things basically uses one more additional field. I've created something like display set. I've defined different data sets to combine in display sets. And if you look at the functions that I use in this case, this is in here. Come on. Further down here. This is the data set you're currently seeing, and there is processing templates. And remember that I said I can combine the summer topographic maps with the aerial imagery. This raster function doesn't really do a lot. The key thing is in here already. If my rows in the table are part of this display set, they qualify for being used for display in this logic. The rest of the information is in the standard fields of the system, which is the scale ranges that are defined in here. But the simple message here is, this is a database. Databases have fields, queries, selections, and stuff like that, and that's what the Mosaic dataset can do for you. With that, jump into some of the fundamentals. Pretext. Because it is a database thing, usually you have two options to use it inside of your ArcGIS. You have either an enterprise geodatabase system or you use file geodatabases. In general, it works in both environments, but just be aware of some of the differences between the two. The idea of the file geodatabase was to be something that you as a single user use somewhere on your machine. You are the one that uses it. It wasn't really meant to be used by 20 people at the same time, so this file server thing that we've been talking about, right? It is quite chatty compared to a very effective real database system. You can run into things like locking there. If someone does some editing in it and some other one tries something similar, then you run into locking issues because it's file-based and stuff like that. Enterprise is really your choice. If you have what we call transactional Mosaic datasets, that means lots of changes in it, many people or several people editing at the same time, live updates while other people are still using it or making adjustments to polygons or whatever, then you need an enterprise system. If it is just about serving something out, that is more or less static. If you are the user of it, if you set something up, file to your database is perfectly fine. Come on.
Can I ask?
Yes.
But if I need to create services from the mosaics, which one is the better?
Again, there is no yes or no. If these services are feeding applications where editing and adding new images and all that is part of the story, it actually needs to be enterprise. If this is a service that is going to be used as a backdrop and then every few months you update the service, you update the file, you can perfectly well save it from a file to database. Because when the service initiates and reads, it does keep the connection, but it only refreshes in a given refresh cycle that is part of the definition of your service. In the properties of the service, you have the refresh cycle time. So usually it reads the definition, it creates the service from it, and yes, it does the queries against it, but it doesn't continuously trigger the database as much. I hope I didn't jump. This is sometimes a little messy here. Come on. No, let's do like this. Okay. This is what I want. So, I said again that very commonly your workflow is you right-click or you use the tool or whatever and say create Mosaic dataset. What you then create is basically the table scheme in the database. Unfortunately, I'm not as bold to say most of you, but some of you probably never open the properties. When you said
always.
Very good. He's a positive example. Stick to him.
He's an exception.
He's an exception. Exceptional. There are properties. These properties are really important. And ArcGIS is setting a lot of defaults in those properties. And these defaults don't always make sense depending on what you do. They might. Honestly, they might likely not. Please go to those. I'll look into one set of properties on a data set in a minute and tell you a few examples. So, the data set as such already has properties. Then, the data set has this thing that you all know, this footprint table that exposes to you. What is the footprint table in real? You tell me.
Geometry.
He's exceptional. Second time in a row. It's a polygon feature class, to be honest. Right? It's a polygon feature class that comes with a set of standard required fields, of which a few are very important. Starting out with a field that is called raster, which is a blob, which exposes to you usually just as the field raster. But as we will see, this contains all important information about every single data set that you add. And it's absolutely open to you to see this information, to change this information, to work with this information. Sometimes you don't have to, but if, it's very good to know. Then there is this geometry, as we will see in a second, and then there is a number of very important fields. At some we will look in a minute. Then, when you start adding data, all of a sudden there's more fields coming into that system. These are usually sensor-specific fields. So the system will try to read common metadata of the data that you add, and then things like acquisition date and stuff like that will be taken from the metadata and will be added to the records where it actually matches. Also means that it can happen, you add several sensors in a row, and then you basically have fields of very similar meaning that show the same content, but for another sensor. You might think of consolidating that then if you want to, but just take it, fields might be added because you add certain raster types and sensors. And then the third thing is, well, at any point in time you can add your own fields, as many as you want. And give it information. Sometimes this can be things like, I have a license to use this data till then, or this is the provider I got this from, or whatever you want. This is the person who added this record or who last edited the record. It's all up to you to add additional fields. When we talk about a database and fields, what is important about a database and fields? Indexes. The more data you have in a database and the more you use fields for certain tasks, the more important it is you have indexes on those fields, so the querying and filtering according to those fields works well. ArcGIS will put indexes on some of the standard fields anyway. You don't have to care about those. But if you use your own fields for certain purposes quite often, please think about adding indexes. Okay. One field in there, as we said, it's a polygon feature class, is the footprint of the element. How does the footprint look? Usually, initially, like a rectangle. Because usually, initially, it just takes the 4 corner coordinates in the reference system used to show where this image is. Does it need to be that rectangle? No. Should it be that rectangle in many cases? No. Clip off no data is a very important step that you could do to take load off the system. Adjust it to boundaries that you want for your service could be a way of working with it. So the initial footprint is just a suggestion. In the end, this is only the polygon that tells ArcGIS, use this part of the image, please. Nothing more. Then we have, as I said, the raster item. We will look into that in a minute, just go through it in theory. In the raster item, everything is stored about this raster, all its properties, and very, very important, there's always, every single time you add a raster, there is a function chain in that digital element. That is the function chain that was used to bring this one element into the logic that allows you to use all of the elements. So it doesn't always look the same for every item you have in there. We look into that. Then you have a second feature class called the boundary. Initially, the boundary is always the sum of all footprints. And then again, it doesn't need to be. If you decide the boundary to be something completely different inside, logically, that area, or maybe even very simplified, large outside of it for certain reasons, that's perfectly fine. The only rule that exists for boundary is it's always only one record. It can be a multi-part polygon, but it's always one record in the boundary. There might be other tables, like the seam line table. Does everyone know what seam lining is? If you have overlapping data, defining the boundary to use between overlapping data, cutting it along a certain line. There's tons of ways to define seam lines. Always use the most centerpiece of the image. Go along natural boundaries, even digitize them. Find the most northwestern piece of every image. I have never understood why people want that. So there's methods of doing that in the seam line creation logic. And then there can be, depending on what you do, there can be a list of several additional tables. Very typical things are if you have photogrammetric data and you build the stereo model, you will get the stereo table. It will always build up a levels table if you have several different resolutions of data in there, or if you build pyramids and overviews. There is always a raster type table that lists all the raster types that you have added to that data set. You can check that if you want to. And very important, there's also always a logs table. Every single thing you do on a Mosaic data set, I recompute the footprints, I add features, I delete features, whatever ends up being in a logs table. That logs table can grow very, very fast to very, very big sizes. Delete the records if you don't need them. It's no problem. Just open the table, take out all. Don't delete the table, just delete the records. The real meaning is if issues happen, you will find them in the log table so you can follow up problems that you had. But if there are no problems, if it just lists, I added these 10,000 rasters, every one entry for every raster, get rid of them. Kill the entries in the log tables if you don't need them. And then you can put on top of the Mosaic dataset, you can put additional function chains. What are they for? They are to give your users, like I showed in my example, selections and applications and even simple analytics of the data on the fly on top of the Mosaic dataset. This functionality of defining function chains and processing chains and attaching them to an image, or in this case a Mosaic dataset, is that unique to Mosaic datasets? It was, it is not anymore. You can attach functions to a single TIFF and give it to someone else so he can exactly use the function chains that you defined. It's been massively extended to support all kinds of rasters. It will always be stored in one of those XML metadata files as a JSON formatted text string, but you can attach function chains nowadays to all kinds of images. Okay, let's get into the properties. You have those slides to remind you, but I will do it on my machine to show you potentially what you should take care of. And I do this actually by going back up here into my database that's not going to live for very long and say new Mosaic dataset. Okay, the name, why not? Why do I have to specify a coordinate system here? And what is it for?
It's always better to keep as the source data the same and the performance is the best. But
are you sure?
I'm hoping. And yeah, it's always important to show what coordinate system.
That's, I mean, you were right in everything you said,
Yeah.
but the reason why you have to have a coordinate system here is actually much simpler. Remember that we said when you create a Mosaic dataset, you will have the footprints, you will have the boundary. You can load data of many different projections into one Mosaic dataset, but then you want to see how they relate to each other. You want to see, is this one here and this one is here. So what this is the projection that's going to be used for the footprints and the boundaries and the extents that you ask for. When you ask for a single raster, what extent does it have? It doesn't mean that you only can serve out this Mosaic dataset in this projection. And actually, ArcGIS does not go through this projection when you ask for the data in another projection. It takes the original rasters and transforms them right into the projection you ask for. So it's not always going through this projection. The main reason for this projection is really the footprints, the boundary, your overall look at the data when you collect different things together. So let's leave it like this. What is this?
I think it takes the parameters from a predefined product already and giving it to the Mosaic dataset.
It just sets parameters of the Mosaic dataset, specifically the band combination, the spectral range of the bands, the number of bands, all these things. There are standards to do that. You don't have to do that. If you do none, then the first data that you load will basically set some parameters of it, but it can be really helpful to do it. When we look at a Sentinel example, maybe a little later, I will show you why. If I would, for example, do this, whatever, and now I open this up, I can see, now, according to the specifications of Planet, the bands, the band order, and the band spectral ranges are set. Why could the spectral ranges be important? Something that hardly any user of us has recognized or uses.
Because they differ, like from Landsat to Sentinel?
Absolutely, yes. And when do you want to use them? Actually, when selecting bands. So for example, you have a sensor that has red on band 1 and another sensor that has red on band 4. They both have red. Red always is in a certain spectral range, right? We have red here too, so we can at least get an idea. It's very common that red at least is somewhere between 630 and near to 700, usually not touching 700. 650, 660 is often the mid-range of red. If I now mix sensors in a Mosaic dataset, one has it on band 3, one has it on band 5. If I know the spectral range, I don't have to care. If I then say, give me a band combination of this spectral range and this spectral range and this spectral range, it will filter out the bands itself. I don't have to care which band it is. Selecting by spectral range can take a lot of load of your pre-thinking of how to combine sensors and bands. So if you have that information, use it. It makes your work a lot easier. But again, you don't have to. So let's keep it simple in this case. Same about this. If you know exactly what you want to create, and it's always going to be the same, add it in. If not, it's going to pick that up from the first data sets you load, and you can change it later if needed at any point in time. So we do what most of you do. You've done that. You say run. We've created an empty Mosaic dataset. If I look at the table, you will see that now I have those fields that I saw in the list before, which are the standard fields that always get produced. But more important, I have this here now, and now I can do what I told you. I can look at the properties of that Mosaic dataset. Even when it's empty, I can start looking at it. There is different sections in here. I'm not so much concerned about this section when I say you should always do something here. There's one thing here that I want you to be aware of. What is this? The source type. The source type is a setting that every raster can have, and also every Mosaic dataset can have, that tells the system how to initially treat this dataset when it has to stretch it or display it. Simple example, if you use generic here, it will do a min-max % clip. So it will clip the upper and lower boundary and stretch the image by default between that. If you have an 8-bit readily processed 256 color values dataset that you have already perfectly prepared, if you, for example, use processed here, that tells the system I don't have to do nothing. I don't stretch it. I just display whatever there is. If it is scientific, it will apply a second order standard deviation stretch and use a certain visualization scheme along a color ramp, expecting these kind of values. So these defines data sets. Elevation will use min-max, strict, no clip, whatever. This defines default behavior of ArcGIS. If you know what it is, set it, and it'll just be easier to use ongoing. Much more important are the properties that are here in defaults, and that's why I said the system will set some standards, but very, very likely this is not what you want. And it starts with the first selector that you have in here. Allowed compression methods. I open this up. What does this mean? When you create a resulting image, however, from a Mosaic dataset, that image needs to be transported to the client's display. for this transport, a transport compression will be applied. And this is exactly what you specify here.
But you need to think at the same time it takes more power from the server also.
Yes.
If you are choosing JPEG or whatever.
Yes. You have to, it's always several things to think about. But what I wanted to mention is, again, if you're working on your machine alone, and this is the processing machine, this doesn't really matter because this is the transfer compression from your graphics CPU to your graphics card. This doesn't really matter. On a server environment, and the same thing applies for image services, this is really, really important. Because if the server does something and he transfers it uncompressed, it could be megabytes. If it's 80% JPEG compressed, it's 100, 150, 200 kilobytes, even on a large screen. So define proper defaults here. Again, this is the default. A powerful client, and let's go back, let's leave this. You know that. A powerful client, this is my service. It doesn't have data yet. But if I look here, and I allow the user to change that, the client can still decide what he requests from the service. If it's allowed for him to change, he can do that. Simple example, you have real analytics that are based on the radiometry of pixels, then a brutal compression will kill the analytic capabilities. If the user knows that and he is fine, he can actually still say, no compression. Deliver me the original uncompressed data. Or he says, no, I'm absolutely fine with JPEG compressed results, right? Here you set the defaults and the allowance list. So go back in here. If you say, no, you can't use uncompressed, but yes, you can very well use LZ77, and my default is JPEG 75. You have set sort of a decent standard, and the data will, in our use case now, look quite nice. Same about the way you interpolate. Same about what mosaicing methods actually can users use. Whoever of you used different mosaicing methods? Who knows what by attribute means? Log raster, closest to center. Have you used it?
Yeah, if there is overlapping rasters, you need to know which the top one, the lowest one, and how to show them.
Exactly. That's the basic explanation of mosaicing rules is if you have overlapping data, what logic defines which image becomes the prioritized image. And there's multiple ways of doing it. And again, this sets the full list and the default list that is going to be used by the system or that you allow your end users to use. This in itself, we could talk about that for hours, but just be aware of a few things. Now, I'm going to show them to you in a minute that you should know. So set proper defaults here. Now we get to some really interesting things. This is the list of these items here. Do you want the system to always clip the raster to the boundary of its footprint? Honestly, usually you want, because you've defined that this is the valid area of the data. I don't know why this by default is off. Turn it on, basically. Same thing with overviews, depends on whether you have overviews at all. But this one is really important. Footprints may contain no data. Default here is yes, footprints may contain no data. It would be good practice if you manage, it's not always guaranteed, not always possible, but if you manage to be very sure that this can't happen and turn it off. Why? It's again only important with overlapping data. If you have overlapping data and you tell the system there is no data in the valid data ranges, then it only needs to find the most prioritized image and it will know this is what I have to display. If it doesn't know whether there is no data, it still needs to check for basically every pixel. Is there a no data pixel in my preferred image? And if so, what is the next relevant pixel? Oh, does this have no data or not? Oh, what is the next relevant pixel? To fill in all the pixel values to show. This costs quite some computing in overlapping images. So if possible, get rid of no data or have it properly defined, exclude it from the boundaries and footprints, and make this an off, and you will have done something for your performance. It could help you quite a bit. In some cases, it makes a big difference. Clip to the boundary is a very common thing too, that you could discuss whether you want or not want it. Then we get to this here. Whenever you do query a Mosaic dataset, it potentially does not only create the resulting raster, but it also creates metadata on that reply. Do you really need that? Very often, very many of you might use the result of that query just as a backdrop image to some additional information. No one ever queries the metadata. People just don't. So if they don't, why create and transfer it all the time? Why not just say, no, we don't need it? Limit it. Same thing about allowed fields. The initial setting here is that all standard fields with all information, remember you can open the table, right, even from a service, will be transferred. I have a hard time finding people telling me why they want to see, for example, those fields. Those fields are just there. Why would I want to see those fields? And there are other fields, and it's your decision to actually say they are relevant to the users. They tell them something. Why do I transfer them? It's all data, right? It's all, with every request, this data is produced and sent to the client, even if the client never looks at it. So make sure you check this out. There is a similar issue here. When you open the table, even on a service in the web client, you can ask it to give you as many records by default, right? Again, I can't give you a general answer, but often if you do work in a certain environment and area, there shouldn't be more than 20 to 50 relevant records ever, not 1,000 or 2,000. Why transmit as a default chunk these many records? Limit it. Now we come, these were all just, minor twitches to think about performance and why do I transfer data and why not. Now we come to a field that might become really important. The Mosaic dataset has a unique field capability, which is this one. It's called coordinate system transformations, and when you open it up, it gives you a user interface to select transformations. You know that ArcGIS in general does on-the-fly transformation of data. Whenever you add something to a map which has a transformation, it will do a default transformation. In ArcMap, you also might know that once you add layers, you can open up actually in the map properties which transformations it currently uses and even change that. Why do you want to change that? Because you want a different transformation. And that's exactly the spot here. If you know I have users that use 3, 4, 5 transformations, if any of those is not to use the standard transformation that ArcGIS would choose anyway, set the transformation here. So I can give you an example from the time I worked in Austria, because I know that when they do the WGS ones here, they often wanted this to be the standard used, and this is not the system standard. So you would take this one, you would add it here to your list. Now if the Mosaic dataset gets the request to supply an image that requires this kind of transformation, it will look up the list and it would use this one instead of the one that is in the system in the backend. This becomes again really important when you do services and stuff where the end user doesn't have a high-end client where he can decide these things. You preset this information and you do it on the level of the Mosaic dataset. Then we have the time settings. you can deal with those as you like. And finally, we come to this one. Again, I have no idea why they have used this as default settings. A Mosaic dataset can be used to download data. In Pro, every single Pro user has the user interface, if he connects to a Mosaic dataset, to download data, the original data behind the Mosaic dataset or converted datasets. The Mosaic dataset again has a property to allow or disable that, and allow the amount or disable the amount. The default is anyone can. I don't know why. I think the better default would be no one can. So that should be enough. No images allowed, but to make sure that even no data, megabytes, whatever is allowed, I would recommend you, if not explicitly wanted, to disable it. The only thing that can happen if users understand how this works and you don't disable it, they start just pulling data to local disks in your organization, whatever they do with it, and normally an organization does not want that. It's just a waste of storage space, basically. So you see, in these properties, there is a lot of stuff. Yes?
Can I ask about this maximum number of rasters per mosaic?
Yes.
Fifth row. Because usually if you are doing always before the creating service this analyzing mosaic dataset, it's like mandatory thing what you need to do. It's always saying that you have this number is too big or too small, or you have too many rasters and this number is small. And is it important to change it, or?
I would be as bold as replying to you, if you don't change this number,
Nothing happens.
And nothing bad happens to you, then you've done everything really well. If this number is not enough, then you have a potential performance problem anyway, because if for creating a single reply it needs to read more than 20 images, then very likely your data is not set up in a very good way. This is a performance protection thing for you. You might know the same thing from WMS services, for example, where they have two limits built in, and we have the same thing. One limit is the maximum size of the image in terms of pixel dimensions that any single request can trigger. And the other thing is, how many images do you need to read to create that result? And you can imagine, in the worst case, a global data set where someone zooms out globally, boop, 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 there are no pyramids or overviews or anything, and now he has to read thousands of images to create a few blurry pixels of the globe. This would be nonsense. You don't want that. So here, you tell the system, if you have to read more than 20 images, and that's the way it is working, you will read 20 and create whatever you can create from those 20, but then you will stop.
Okay.
You can simulate that.
It doesn't need to be exact the same number of how many rasters I have inside the mosaic dataset.
Absolutely. No, it shouldn't. It should be way less. It should be way less.
Because the name of this property is maximum number of rasters per mosaic. It shows me like...
It means not per mosaic dataset, it means per mosaiced result image. But you're right, the naming, if I take your comment, is not perfect. It should be per mosaiced image. Yeah. I have to take a note of that.
The default value 20 is okay. Even if I have like 1,000 orthophotos inside the mosaic dataset.
Yes, if your system is set, I'll show you in this example again that we have here from Zurich, and for that I'm just turning back to, I'm just turning back to the most simple way of looking at the Swiss image datasets, and I'm turning on the footprints, and now you can see the level of footprints you see now, these square things. These are the tiles of the high-resolution aerial images, right? So you could actually see now, if I would have requested this for those high-resolution imagery tiles, I would have had to read 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 images. That's below those 20. And if I would zoom out more, Now I would probably reach the 20 already with all those little edges, things here around it. And now the question is that okay? Because they are very well formatted and I want that to happen? Or do I have to rethink my strategy? Would that be another level of data where there is an overview now or another data set? That's the whole meaning of this field. It protects you from defining something that starts reading tons and tons of data. And that's why I said in a well-defined Mosaic dataset, very likely that's never going to be a problem because you will never have to read 20 files to create one final output. But it might be, it might become.
But it always gives the warning. If I'm making this analyzing Mosaic dataset, it always gives the warning that this number is, let's say,
too low.
Too low, yeah, because I have much more rasters. Oh, yeah.
It will depend the warning on the min and max PS things. It analyzes those and it defines the warning from that. It often says it should be 50 or something, but if you're confident and it's working performantly the way you do it with your 20 setting, I'm much more happy with your 20 setting than setting it to 50. But I can give you an example of, I had a project once, very long time ago, after German reunification, where for Eastern Germany they had tons of old historic property maps, Russian property maps, old German property maps, and actually the German agency that had to decide about giving back property to people who asked for, hey, I had this before this became Russian and now I want it back. They needed a track of records. And they had scanned millions and millions of those sheets. And they had to evaluate. And there we had to set that up to 50. And it was really 30 files that lay, and they wanted to be able to switch through those files after they loaded the initial 50 and see where they get the best information from. So there is no or yes and always use this and always use that. It's depending on the use case. But it's good you asked, because that is, sometimes people wonder, hey, it doesn't fill the whole screen, it doesn't show all images, and then it could be because of that setting action. Yeah. Okay. That was that. How much time do we have?
2 days.
Sorry? 12:15 is lunch, so I should, yeah. I'll try to do like 20 more minutes on this and then move to the oriented imagery part. Okay, so this was the properties. Now I want to look very briefly into the topic of the raster functions on the incoming side of data. Remember, and we can use this data set, it really does not matter. Remember that I said when you load data into it, you have this field called raster that basically always just shows raster because it's a blob field. How can you look into that field? Do you know that? How can you see what's actually in this field? The most simple way, and now let's select just 2 out of this, is if you've done any selection in here and if you highlight the image sublayer here, there's other ways to get there. In the context menu you will see this data tab, which actually gives you a lot of options to see into the data in detail. One way now of looking at it is the so-called Raster Items Explorer. Who has ever used that one? Not too many of you. So select records and use the Raster Item Explorer. Now you get an interface with 2 tabs. You could also open this one up and do a selection instead of what I did, right? And do a logical selection. And on the second tab, you can now actually go through every single item that you have pre-selected and get information on that item. If there is a thumbnail or something, it will show up here. In this case, that's not the case. But now I selected here record number 2. You can see that GA, whatever that is. And now you see 2 levels of getting to the details. One is this one. That's what you will see from properties in the catalog from rasters, as you know. If you have a single raster somewhere on disk, this is the property sheet of it, basically. Now this is the item in your Mosaic dataset property sheet, stored in this raster field. So you exactly see what this item is, what the spatial reference of the item is, you know, all those things that you potentially want to know if you've created statistics and so on. And here you can actually see what the function chain is that was used to bring this item into this data collection. So if I open this up, yay, this is fascinating, is it? Taking a source data set. This is good. No more cursor. Frozen. Interesting. Okay, let's go there again. For the fun of it, take something else. Let's take this one. And then open that up again. Okay, I've chosen a different one now, so you can see that the function chain that was used to import that element might actually look pretty different. So this is a function chain that is used to get this data set into that compilation of data. Could you have known this function chain before? Could you have seen it? Where does it come from? Why is it using this function chain to get this item into this data collection? Because you told it so. Where did you tell it to do that?
In properties, Mosaic data.
In properties where?
In raster properties or in Mosaic dataset properties?
No. These are the raster properties, that's correct, but where do you have influence on which function chain is used to import something into a Mosaic dataset? I tell you, it's a very stupid answer. In add rasters.
Yeah, but we didn't cover this topic part. We didn't add any rasters yet. So
that's why we look at it
because
right
there's
now.
Also a lot of
but it's just a smart answer. Yeah. Okay, so let's look into this. If I say add rasters, again, many of you might have data deliveries where they just never change this. They say, I want to add some raster datasets, maybe coming from a folder, and then they specify the folder, and then they say run, right? And then it does magic. You probably skipped sort of what's in here, in these two lines and in these properties. This is the unique power of ArcGIS and the Mosaic dataset that you skipped. Here you find the raster types again, right? We talked about the raster types when we looked at a single dataset on the disk that has a certain raster type and how ArcGIS knows what it can do with it and how it can interpret the data. The same thing happens here, and I'm using the same example for your easy understanding. If I say Sentinel-2 here, all of a sudden this list here changes. Remember that list? That list is pretty similar to what we had when we said I can drag Sentinel data into the viewport and then it knows what to do. The same thing happens here. I now say I want to add multispectral data, and all of a sudden I see this button again. This button looks very much like the button we just looked at. Because now I can look at the function chain that ArcGIS will use. This is now the wrapped knowledge inside ArcGIS, right? To integrate all multispectral bands and create this record that we just looked at. Does that mean you have to follow exactly that rule? No. You can either come on, where is it? Here. Start creating a new import template, import an existing import template. So it's you who decides which function chain is used to import elements, which can become pretty important if you want to bring sensors together, customize things, or whatever. Both elements here, raster type and processing template, are customizable. It becomes a little bit more difficult here to create your own raster type, so-called custom raster type. You have to write Python. So that will be something you better go to either AlphaGIS or you learn where it is. It's on GitHub, how to create a custom raster type. Again, to give you a simple example, I have a few in here that are not in your distributions. This is one of them. This is the International Red Cross, and the International Red Cross has access to data collections, in this case of Digital Globe, that are brand new. They are not yet readily processed to the level that you have when you ask Digital Globe to sell you data. So they needed a custom version that goes to the metadata, the way they get it, and import the data. And again, this is Python code, and then again, down here, it's pretty similar. They just wanted to be able to use multispectral or panchromatic. But this is a custom raster type that does, in the back end, totally custom things. Another one, also a very nice example, also from a humanitarian aid company, is this stuff here. I will show you a multidimensional example later. Médecins Sans Frontières has access to humanitarian data about flooding scenarios in different countries. This is cloud stored data, and this helps them to read from the cloud store, create a Mosaic dataset, make it multidimensional, and use it right away, wrapped in a custom raster type. Please, again, we can't create one now or anything, the time is not there, but understand this is wide open. If you get certain data, we've had all those cases where every single file comes with a custom JSON documentation, or where you just get a list of rasters and the bands need to be combined in certain ways. All of this can be done through these two elements, so that if you have that as a repeated process, please learn how to do it and how to make it very effective. One more on this thing here. Is everyone aware of this switch here, Enable Pixel Cache? This is again mainly meant for use with cloud stores. It will create a local pixel cache in a storage location you define, so that you do not have too many back and forth connections to cloud. So there were two Julia was here and someone else in the break asking for direct access to Planetary Computer and stuff like that. If you do use these data sets across the cloud boundaries, do yourself a favor, turn on this feature, define a local folder so you cache locally there, so that you do not have to go back and forth to the cloud all the time. This will be embedded in your records when you do that. Okay, I'm ending this section on this Mosaic dataset data model with another example, same way as I started. This is an example of elevation data. We already, yes?
Question about the adding rasters, so that the input data filter, was it rejects there that you write?
Yes.
Yeah, built-in rejects.
Yes. You saw that line. This was basically this formatted data stuff that they get. They get it as zipped. So we searched for the zips and we read right into the zips and extracted the geography information from the zips and then made the rasters get ingested. And yes, it used a regular expression to find specific files in the folder structure. Yeah. Okay, this is an elevation example to point out another important thing about functions and about general capabilities within the Mosaic dataset. I have a lot of templates to visualize this data in here, and some of them are really simple. So yes, I can just say, give me this as a hillshade. Then I can also say that this is the DTM hillshade. I actually want a shaded relief of digital surface model, so not the digital terrain model. What does that tell me? This is again a data set that has both raster kinds in it, the surface model and the terrain model. If you remember this Swiss example, whether I use surface or terrain is pretty simple. It's a database query based on a field. Right? But now here comes the interesting part. If I go back here again, I have a processing template that says do DSM minus DTM and classify it. Okay, slowly we get to areas like you mentioned. Yes, there will be processing happening. In this case, it involves several files and things happen. But how the hell did I now do minus of a DTM and a DSM inside a Mosaic dataset? Well, let's look at the function again to understand this. The Mosaic dataset is here. Here are all the function templates. And here is the DSM minus DTM. And again, the key thing doesn't happen in the function as such. For now, we will look at that in a minute. The key thing already happens in the property of the function. Have you ever seen that the type of function has 3 entries? Most of you always use the one that is Mosaic, but there is 2 more. Read about them. The most interesting one is actually item group, which allows you on tiled overlapping data of the same tiling scheme and whatever to address tiles by database field names and then do something with it. So here I defined that my group name is in the field group name, my tag name is in the field tag. Let's look at the data. The tag specifies whether it's a DSM or a DTM. The group basically is the tile name of the predefined tiling scheme. So that means for every single group, like 35.2, I have a DTM and a DSM. And that allows me to do this function. So going back in here, I now look at it. I now say I have the selection by these 2 fields, right? From the same tile, this is the DSM and the DTM. Now I do a minus of those 2. I remap the height values to the classes that I want to use. I assign the attribute table to the elevation values according to my liking. And this produces me dynamically from the raw data this classified scheme of basically here building height and vegetation height and whatever in the center of Vienna as a result. So, takeaway of that is the functions can be applied at any level. Input level, output level, item group level, item level. They can be They can have parameters, they can have the function chains you want right on import or changed afterwards. If you want to change the function chain of a group of items after you have loaded them, what do? Delete them and reload them? No. This reaction was really good. How do you do it?
I'm not so sure.
Assuming whatever, you have made a selection, it could be hundreds of items, these need to be changed. That means you have a selection. So here, selection, batch added raster functions. This goes into that raster field, into the function chain, and now you can decide, do I have to add something, like everyone gets a stretch? Do I have to modify the values of something? Or do I have to update the values of a certain raster function for those items inside the function chain? If I'm doing this through the UI, and you want to be much smarter to do it, and you do it automated, how do you do it? There's a Python function for exactly that same thing. It needs you to create the Mosaic dataset as a layer, so you can apply a query, and when you have applied the query, you can change the raster functions same way, automated through script and whatever. When you try this out, do yourself a favor, do it on copies of the original data, so you see, does it do what I want, and only then do it on the final dataset. It's basically easy. Okay, I have put things, ideas, stuff into those slides. We now looked into this here. Please, main takeaway of this is there is much more under the hood than it seems. And if you have a question how to do something, how to approach something, come back to us. We are more than happy to help you to figure out how to do it, because it's very, very likely possible. Yeah, I talked about this. Maybe, oh no, it's not. I don't have it with me. Okay, forget about that. Yeah. Okay, I spend a little more time on that than I will spend on oriented imagery, specifically because we had that yesterday. And I actually want to ask, who saw the oriented imagery presentation yesterday? Quite a number of you. What is your interest? I mean, I don't want to repeat like most of it, right? Who has potentially the requirement to ingest his own kind of data? Yeah. So not like the standard workflow of doing it. Then I'll do a brief for those who haven't been there, and then we'll add this topic just or tease this topic in the next 15-20 minutes to see that. So for those who haven't been come on in the presentation yesterday, start with one or two examples. I'm using different ones for those who have been there yesterday, so you see other things, and then look into the details. So let's use this one to get started. This is you saw how I got there, a collection of samples that you can also use yourself to understand what's happening. And the whole idea is this. The green area in this map here symbolizes an area where there is so-called oriented imagery available, which means there have been images taken with whatever camera system. In this case, it's a 360 camera that span this area, and we now want to be able to see details. So here is actually a dam. So if I say, hey, I want to see this area a little closer, yeah, I should have highlighted this before. Okay, this area a little closer. Yeah, okay, here it is. Then I see this dam. On the map, I see where I'm currently actually looking at, the direction and sort of the distance. And if I, I extend the range of the distance, now I'm looking even further into the landscape. I'm looking into some slightly different direction. I'm looking more down on the dam surface. It tries to give me an impression of where I look at and where the geolocations are on the map and in the related imagery. A second example. That was a lot nicer a while back, but it's still usable. This is basically the campus of Esri in Redlands, and there was a construction for this building E, and for a while they took images like regularly to show what the progress on it is. Now it's basically done. But here you have an interface to say, okay, how did this look a while ago? It will figure out a similar image. These are not 360s, these are normal drone taken images. So now I can start inspecting items in here. You can see it's pretty high resolution. I have different dates, and then the rules applied here on that side are pretty much the same as they were on the other data. This is a hobby of Jack. If he does gardens or whatever, he will landscape design, and he will definitely put some big rocks there and some nice trees, always. So this requires you to be able to integrate that data into ArcGIS, though it's not regular imagery data, and that's done by a very much simplified data model, which is point-based and which has attributes that allow the system to map this data to the ground, taking into account an elevation model and the camera parameters like the focal length and the field of view of the specific cameras that are used in that cases. The implementation in ArcGIS, we can go to Pro again, has become a standard item of the data model. It used to be a custom implementation that you did a free download and then you could use that stuff, but now it has become a standard element. So now if you're inside any geodatabase environment, you can actually create new oriented imagery data sets, and similar to what we had before, you have to give it a coordinate system and give it some name, and then it becomes an empty oriented imagery dataset. Lots of things that I have said about Mosaic datasets are similar valid here, but not as critical. An oriented imagery dataset also has properties. It has overall specific oriented imagery properties. These are again default values that you can set here, with the advantage that you do not have to set them on every item then if you want. So if you, for example, know these images are all of orientation type whatever, nadir, which means looking straight down, and you have all this information for the camera you're currently using, you could set that as a default, then you don't have to set it on any of the items and it will just use that default. It also has some very, very useful dataset level settings that you can add on the level of for path, prefix, suffix, and so on. One here is self-explaining. You can actually register which digital elevation model it should refer to as a dataset property. Much more interesting are things like this: image prefix and image suffix. Think about, you create that data set and you prepare it on your local disk, but then you want to move all the images to an an HTTP location where everyone can attach them, or a cloud store or something. You just use the prefix of the image to specify where the images actually are. So when you initially started that, it might have been something like I had that on my C images whatsoever, and then there would be all the images, and then you shift them to the cloud, and all you do now is say this is now at HTTPS whatsoever, and you've changed the data set, now going and accessing all these data sets in a HTTP location. That's a very common workflow, because in the end, most of the time, if these are large collections, they will end up in a on a web server or a cloud store, and you will get an HTTP prefix to them. So these things happen on the level of the oriented imagery dataset and not on the level of the record. Now, let's get one. Just open a project that has some data sets in it. Same one I used yesterday. Those who were there yesterday remember that example captured by my mobile phone, and that would be the table of this oriented imagery dataset. You see here the image path still points fully to a local JPEG file. You would definitely change that if you want to make that some public offering. And then you see the level of the dataset properties, which are usually specific. Remember I said this is a phone, and the phone did have direction, but it doesn't have any tilt or roll or pitch or whatever. You can clearly see that in the dataset. It loaded the data, but it couldn't get any values for pitch and roll. It has a value for heading. That's why it shows in one direction. It also, from the sensor and the image size and some other stuff, it was able to calculate the horizontal and vertical field of view. Sometimes that is a property that comes with the EXIF information. In other cases, the system will calculate that for you. Why is there nothing in near and far distance? Because that's been set as a default on the dataset level in our case. That's the mix between record level and dataset level. The images don't need to be rotated, and that's all you need to be able to now use this oriented imagery data. And then again, the green areas show some data. So here there is an image on my disk that I can now access and go to. Depending on the image format, and specifically relevant in the cloud, you might have the ability to see other images that overlap in the same area. Look at this. These are JPEGs, and it doesn't give me that ability. That's because JPEGs don't really have proper internal pyramid capabilities. And the system turns this option off if there is no proper internal pyramids available. If this would be cogs, this would show up. So some intelligence that we built in, but that you might also find restrictive, it does make a lot of sense on data sets that you publish and use in large environments. Now, adding data to this. Should have this in here. Yeah. This was my local imagery data set. Right-click, add images, pretty much like add rasters, allows you to load anything that is inside the range of standard supported data. So that would be the mobile phone stuff that I showed you, but also other attributed supported sensors that you basically have. Then it asks you to define at least roughly what kind of data that is, because you can combine several of these into one data set and usually specify a folder here. And then you might filter the data, again similar to what we had before, or do a selection. And if this data is table-based, you might decide to add additional fields or not additional fields. That's basically all for the standard input. If that works for you, fine, then you're done. The images are in, you can use them. The oriented imagery domain is a domain where typically people come with very, very many different data collections and attribute rules and stuff. For that, and that's what I want to spend the last few minutes on, we have created a very open environment for you. To get started, you have to learn the table structure. So, oriented imagery table. Schema. If you are capable of creating a table that adheres to the rules that is described in this, you can use the standard input tool and just specify the table as the input. If you can write out this table from somewhere, you specify this table, it will just read it in, you're done. Very nice. So you see which fields you have to have and which fields are optional. Recently, a lot of things have been added to this. So we have heading pitch roll, we also have omega phi kappa, we also have radial tangential angles, and where was it? The matrix values here, the M11 till M31, if that tells you something, matrix of 9 values. So different things that are supported. So if you are capable of providing this table, that's sort of the second easiest way of doing it. If you want to avoid to create that table and you have specific data sets and specific data formats, there is the oriented imagery custom input types. And that's again part of the documentation, and it tells you in code and in examples what you have to do to write in Python a custom input format. If you've done that, you have an extra tool here, which is add images from custom input type. The input type, this Python thing, will be put into a certain location in your installation, and then you will have a drop down of custom input types. Right? You see a few recent ones that I was working on or had used for our Czech colleagues. Some custom city mapper import. This is frame camera table. This is a mobile mapping system from Leica in 2 versions, and this is a custom version of a folder implementer. Any of these, if you have created a custom one, will be able to give you custom input parameters, and when you run that, it will be imported into the frame camera table the same way as you have. I'm mentioning this because this is way more than we had before on when we still had this non-standard oriented imagery thing. And for those of you who are really into these topics of programming and customization, and I know at least one here in the room is, if you go here to resources, oriented imagery, there's something really interesting in here. In the custom input types, in the sample, it's already in the sample, there is a little thing called utility Python. And if you open that up, it's actually revealing everything you need to know or do to convert any other kind of metadata into these values. So if you are having data in, where are we? here, if you have the rotation matrix and you want to create omega phi kappa from it, or other way around, you have the rotation matrix and you want to create heading pitch roll from it, if you need to get the far distance or the near distance based on the camera height, the camera pitch, and the forward field of view, all these things are absolutely open to you. You don't need to make another math degree to understand how you map, right, angles and values. It's all there for you. Yes, you have to take your own data and data structure and understand how you do these trigger these calculations from these utility files, but this is super open compared to what it was before. It gives you all the knowledge that you ever need to integrate things in oriented imagery. This has made a number of customers very, very happy. Yes, sometimes they needed our help, but it's super, super easy nowadays to do that. So that's the takeaway for oriented imagery, in addition to what we spoke a little bit more about yesterday. Last thing here is repeating again that it has become a part of the standard data model. Now, if you look at this in ArcGIS Pro, you really see that this is an oriented imagery data set, right? It's a little different because, as you know, in the table you recognize it's basically a point feature class with attributes. That's all it is. But it has a certain data structure. If we go to any ArcGIS Online, or in your case it would be your enterprise environment, and you go to your content, it looks a little bit different. Let's go to oriented imagery stuff. Come on. Sorry, wrong one. It's weird. Now I'm confused myself. I thought I was sure I had this. This looks like it should look crazy. So this is an example, and you see here it appears as a feature layer, a hosted feature layer. And if I add that feature layer to a map, it will recognize that this feature layer is an oriented imagery layer. And if I now go into the different sub-layers that it has, and I, for example, select this sphere thing here, we should see come on. That's the interesting thing about oriented imagery. You never know what happens overnight.
It's developing so fast.
Yeah. We should see the icon that allows us to use oriented imagery on this one. Okay, I'll skip that till after the break. I don't know. The icon should be just here.